Alright. Wow, that was very, very loud. Sorry about that. Okay, that was the second one. So, like I said yesterday, the fact that there's a minus here in front doesn't actually change much. It just makes that the graph ends up in like different blocks. So you are still finding your x asymptote in the same way. It's x minus 1, so we say the asymptote is x equals positive 1. Remember, the x is always different. And then for the y one, you take the same sign there, so y is equal to 2. For the y-intercept, same thing. You're going to just take your equation and make x 0. So I just said there's 0 minus 1 is negative 1, right? Now, guys, what's going to happen here? A negative and a negative, that's going to make a positive. Hey, those two minuses are actually going to cancel each other out. So, but you'll see it anyway. If you type that into the calculator, even if you just type 0 minus 1 in your denominator, you'll get the same answer. So you get a y-intercept of 5 from that. Your x-intercept, a little bit more complicated because of that minus. So what happens here is the plus 2 moves to the other side, it becomes minus 2, right? Then you do exactly what you did in the previous one. And actually, guys, if you wanted to, you could have already seen from this line that those two minuses are going to cancel each other out. Right, do you remember in like lower grades when you got something like negative x equals negative 2, then your teacher might have just said, okay, you can cancel out the minuses, right? It's a similar situation, or the same situation actually happening even in this line already. You could have seen that those two minuses are going to cancel out. Okay, but if you didn't, that's fine. You still had your negative 2, you could have just taken that x minus 1 over to the other side, which is what we've been doing the whole time. And then here, it was probably a bit easier maybe to see the minus and the minus are going to come out. You need to now move that 2 over to the other side, because remember, we're trying to solve for x, so we must get everything away from the x. So the 2 you're going to divide by on this side, and then you must add 1. So that minus 1 becomes a plus 1, and you're ending up with an x-intercept. Okay, and this one was quite nice because when you actually just plotted all the points that you got, you didn't have to calculate any other points. So I'll just show you there on the side, you have our y asymptote, y equals 2, right? Then you have your x asymptote at x equals 1. You have your y-intercept at 5, and you have your x-intercept at 2.5. Okay, so you actually did have a point on each part of this graph, which was nice because we didn't have to calculate any other points there. So you could just draw your graph so that it is going kind of towards your asymptote. Right, it mustn't curl away from the asymptote again. So that side, and then you have that part. Do you guys see the minus didn't actually complicate your calculations that much more? It's just with this step over here on the side where you have to cancel off the minus. Okay, your axis of symmetry. Like I said yesterday, the fact that there is now a minus in this equation doesn't change the formula for the axis of symmetry or axes of symmetry. You are still going to take your denominator exactly as it is and your plus 2. Okay, so you have your first axis of symmetry, which is just the denominator and then plus 2, and you simplify that. So this axis of symmetry has a y-intercept of 1. So you can see I labeled it there. And remember, the axis of symmetry always goes through the point and intersection of the two asymptotes, through that cross point thing. Okay, and then we can just draw it here. Okay, and then the other one, that one is similar, it's a little bit more complicated. So you put the minus in front of that bracket thing. So the minus goes in front of the denominator, and then plus 2, and then multiply the negative 1 in, and then simplify. So this one has a y-intercept of 3. Alright, so there you see my point at 3 there, and again it goes through that same point. You know, guys, they might ask you to find the point of intersection of the axes of symmetry. All right, so we're going to write it here underneath. So the point of intersection of the axes of symmetry. That's actually a question that they ask quite often. And it sounds quite complicated, right? It sounds like, can anyone remember what we do when we find the point of intersection of two lines or two graphs? Yeah, you're supposed to make them equal and solve simultaneously, right? In this case, guys, we actually don't have to do that, because if we're looking at the graph, the axes of symmetry are these two purple lines, right? And where do those two purple lines intersect? Where do they cross? At the point 1 and 2. At the point of intersection of the asymptotes as well, right? We're looking at this point here. That point. That point is the point of intersection of the asymptotes. So how are you going to know what the coordinates of that point are? It's the x value of the x asymptote, right? And the y value of the y asymptote. Always, okay. So this point is the point of intersection of the two asymptotes, but it will also always be the point of intersection of the two axes of symmetry. Okay, I'm going to write that down now because I said lots of words now. Maybe it just didn't all go in. All right, so point of intersection of the axis of symmetry is equal to the point of intersection of the asymptotes which in this case is the point 1, 2. And now I'm just going to write 1 is coming from the x asymptote. So guys, whatever your x asymptote is, if it's x equals 1, x equals -1, x equals 5, that is going to be the x value of that point. All right? And then 2, the y value of the point, is the value of the y asymptote. You're not actually ever going to have to do a calculation for that. Okay, if you have the equation of the graph, you can get the asymptotes. Okay? And that means that you can get the x and the y values of the point of intersection of the asymptotes and of the axis of symmetry. It's always the same point. Are there any questions on hyperbolas in general before we are going to come back to parabolas and hyperbolas again when we mathematics graph type questions and also finding the equations of it. We haven't done those types. I'm going to come back to it again. If you are ready, you can write the next heading so long, which is drawing an exponential graph. That's the next heading. heading. And we're just going to write some notes. And then we're going to do examples. Okay, the standard form, guys, is y equals a times b to the power of x minus p and then plus q. The exponential graph is the only graph that actually has 4 variables in the standard form. So we have A, and then we have B. Now guys, B is always the number that is the base of the exponent. Okay, so sometimes you won't be able to see A. You'll see now, I'll write down some examples. So the B value is always the base of that exponent. And something that is also important about B is that B can't be negative. All right, so cannot be negative. I think you might remember from last year, you can get like a negative 2 to the x, right, as an equation of an exponential graph. But if your equation is negative, it's actually the a value that's negative, not the b value. Okay, so a can be positive or negative. Now what happens is your q value, just like with the hyperbola, your q value is going to give you the equation of your horizontal asymptote. All right, so that is similar to the hyperbola. And then if your A value is positive, then your graph is going to lie above the asymptote. But if your A value is negative, then you can make the conclusion yourself. The graph is going to lie below the asymptote. Okay, so when we're drawing a graph like this, you are obviously going to have to draw your asymptote. Again, you will get 1 mark for doing that. Okay, so the asymptotes are nice. They're easy to see from the equation. And guys, also because this is a y asymptote, it doesn't change its sign. Okay, so whatever it is in this equation, if it's a +1, the asymptote is at +1. If it's a -2, the asymptote is at -2. Okay, so the y asymptote never changes its sign. So whatever the constant term is, whatever the one is that's just a number, that is your asymptote. An exponential graph does not have a vertical asymptote. Okay, we'll always just have one asymptote. But now we do have a p-value. Now guys, what this p-value does is actually something that you can't really see when you're drawing it. But the p-value takes your graph and it shifts it to the side. Okay, so I don't really have space for that now, but maybe I must just write it like on the side. P shifts graph to the left or right. It's not really something, like I said, that you can see when you're looking at the graph or that you even need to really think about, because we're going to find the coordinates of points and we're going to plot them and track them. Okay, so even though the exponential graph seems very complicated because there are 4 letters now, right? It's an A and a B and a P and a Q. It's actually not that difficult to draw. The thing that might be difficult for some of you guys is actually solving for X when you have to find your X-intercept because it's going to be an exponential equation. Okay, which we did early on in the year. So that might be the tricky part of the graphs. Okay, when you are finding your Y-intercept, same thing as with the hyperbola. So you are going to make X equal to 0 in the equation. So you're going to have your whole equation, X you're going to make equal to 0, type it into the calculator, that will give you your Y-intercept. Okay, again, if you cross that point, you get a mark. All right. So here you can get 2 marks very easily. You can get a mark for your asymptote. Sorry, I don't know why I'm taking so graph today. You can get a mark for your asymptote and a mark for your Y-intercept. Those are easy to get. Okay, the X-intercept, like I said, is where I think some of you might struggle a bit. Is just to solve for X there. So again, just like with any other graph, you're going to make Y equal to 0 and solve for X. And this solving for X is an exponential equation. Because that X is always on an exponential graph. Okay, we're going to do a few examples. I'm going to start with one that's quite basic, just so we can get the actual calculations correct. Guys, one thing about an exponential graph, you are going to need 3 points. Okay, so I'm going to write that. You need 3 points. So it is going to be your Y-intercept and then 1 on either side. I'm going to move this down. 1 negative X value and 1 positive X value. So unfortunately, for an exponential graph, you are always going to have to choose an X value. Because if we're looking at the points that we're going to get, we're going to calculate our Y-intercept and the X-intercept. That's only 2 points. Okay, it can only ever be 2 points. So we are always going to have to choose one X value to sub into the equation to get that 3rd point. Guys, the nice thing about the exponential graph is that it's 1 negative X value and 1 positive X value. Okay, so if your X-intercept is a negative value, you're going to choose a positive X value. If your X-intercept is positive, you're going to choose a negative one. Okay, so you'll see when we're doing examples, but it's not, it's not too bad. The whole choosing a point thing. Okay, can we go to an example? You guys can write examples so long. I just want to check here. Oh, it is. Okay, I'm going to start with the first one. It's going to be Y equals Sorry, I'm just looking. Sorry, I was checking what is the X-Intercept. Okay, let's do 5 times 2 to the power of x. A very simple one to start off with. All right, what is the identifying factor here? How do we know just by looking at this equation that it's an exponential graph? The x is in the exponent, right? Exponential graph, the x is always in the exponent. So this is the identifying factor. That is how you know by looking at the equation that it is an exponential graph. So I'm just going to write there x in exponent, therefore exponential graph. Okay, now guys, do I have a q value here? Remember, q is a constant term, right? It's a times b to the x minus p. We don't have a p value here, it's just x. And then plus q. I'll just write that on the side. Y equals a times b to the x minus p plus q. You guys agree that my a value is 5, right? The value, the fact that it's a 5 doesn't really matter, but we can see that it's positive at least, okay? So this graph, I'm going to write here, A is positive, so therefore the graph is going to be above the asymptote. There's no p value, right? P is here, x minus p, there's no p value, it's just an x. So that means that the graph isn't shifting to the side. Doesn't really matter, we're just going to find our coordinates and plot there. But now guys, the fact that there's no q value written there actually means that our q value is 0, right? So I would like you to take a different color if you have, or maybe you can highlight it, or you can do it in pen. So just put a plus 0 there. And let me just take a color that's a bit lighter. You can actually see. Okay, there, plus 0. Now guys, that doesn't mean that we don't have an asymptote. That just means that our asymptote, our horizontal asymptote, is y equals 0. You are always going to have an asymptote, okay? But it might not be like y equals 1 or y equals -2 or so. But guys, the line y equals 0, this is actually the x-axis. I don't know if you guys know that, right? The line y equals 0, that is actually the x-axis. Okay, at y equals 0. If you're thinking of your confusion plane, y equals 1, right, is where y is equal to 1. Y equals 0 will be where y is equal to 0. That's actually the x-axis. Okay, so for this graph, our x-axis is going to be our asymptote. Now, if I'm saying that to you guys, if I'm telling you that the x-axis is our asymptote, you think I'll be able to find an x-intercept? What is an asymptote? Can the graph go through the asymptote? No. So now if I'm telling you that the x-axis is the asymptote, that means that this graph can't have an x-intercept. Okay, I'm going to write it here at the bottom or underneath. X-axis is the asymptote Therefore, graph cannot go through the x-axis. So that's what an asymptote is, right? A line that the graph can never touch, or it can never go through that line. So if the asymptote is the x-axis, the graph can't go through the x-axis. Therefore, graph does not have an x-intercept. Yeah. So for an exponential graph, it doesn't have a vertical. That's all. Okay, if this was a hyperbola. Okay, so that's a bit complicated. Yeah. Okay, so that's a bit complicated, guys. That means that we can't find an x-intercept when we actually try to solve it. Okay, so we're still going to need 3 points. We can still find a y-intercept. Let's do that. The y-intercept, we are going to make x equal to 0 to make or to find that. So for the y-intercept, make x equal to 0. All right, so in our equation, we're going to say y is equal to 5 times 2 to the power of x. But now we're supposed to make x equal to 0. So that's going to be 2 to the 0, right? What is 2 to the 0? 1. Oh, sorry. So what do we get here? 5 times 1. Which is 5, right? If you're not sure about that, you can type it into the calculator. That's fine. So the y-intercept of this graph is at 0, 5. How many points do we have? 1. How many points do we need? 3. So we are now going to have to choose a negative x value and a positive x value, because that's what we need, right? We need our y-intercept and then 1 point on either side. So what do you guys want to choose? You can choose anything. What about negative 1 and 1? Okay, is that fine? You can choose any negative x value, any positive x value. Okay, so I'm going to write here. We need 3 points. Therefore, choose a negative and positive x value to sub in. Okay, so I'm going to sub in negative 1, so we're going to say x equals negative 1. What am I subbing it into? The equation, hey? Right, the equation is saying y is equal to. So whenever you take an x value and you sub it into this equation, it's going to give you the y value that goes with that x value. Okay, so we're going to say y is equal to 5 times 2 to the negative 1. So that's y, so that's 5 times 2 to the x, but now x is negative. Okay, you're more than welcome to type that into the calculator, or you can do it in your head. You are going to get 5 over 2, which is 2.5, right? So that is our first point, negative 1 and 2.5. Or you can keep writing it as 5 over 2, or you can write it as 2.5, it's up to you. And then we're going to sub in x equals positive 1. Guys, I'm just going to say again, you can choose any negative and positive value. If you want to do 2 and negative 2, you can do that. If you want to do negative 3 and 3, you can do that. Okay. I normally just go with 1 and -1 because they're the easiest ones to work with. So we do the same thing, we sub them or sub that value rather into the equation. So 5 times 2 to the x becomes 5 times 2 to the 1, which is 10, right? So our next point is the point 1 and 10. Now we have 3 points. Okay, I would like you guys to quickly plot those 3 points. The points face out, okay? We have, if we're just looking at the y values, we have 2.5, and then we have 5, and then we have 10. Okay, so yeah, maybe use one line as 2 units on your y-axis, which will make it a bit easier to draw. And what happens on the x-axis again, guys? What is the x-axis in this case? It is actually the asymptote. So we do have to draw it, okay? And then maybe just draw 1 or 2 units underneath the x-axis as well. So do that on your own quickly, and then I'll show you what mine looks like. Guys, when you have your 3 points, you can connect them. Just again, you're going to make a curve. And now, because your x-axis is an asymptote, it needs to go towards that x-axis when you're drawing it. Okay, I'll show you mine just now. I do have a rule earlier often. They a toilet roll anyway, guys. You can see it. Um, um, we can go look up the bottom. No, actually, our use Okay, can I show you that one? Right, here we go. Now guys, since the x-axis is the asymptote, you don't have to draw anything in here. Normally we draw our asymptote in here with the dotted line, but obviously it's already there, so you don't have to draw that again. You need to plot your y-intercept and then the 2 points that you got. So the one was -1 and 2.5, and then the other one was 1 and 10. And then you just connect those 3 points. Now guys, the good news about the exponential graph is that it doesn't have an axis of symmetry. Okay, so that's quite nice. We don't have to worry about that. We do have to be able to write the domain and range. Okay, so we'll do that quickly. Luckily for this one, it's actually quite easy. Okay, so domain. Remember the domain is all the x values. Right, now what's happening along the x-axis here? What's happening on the left-hand side? It has an arrow, so we're going to negative infinity, right? And what about the right-hand side? There's also an arrow, okay? It's steeper, obviously, but it's also going to keep going and going forever to positive infinity, okay? So, and that's always going to be the case with an exponential graph, guys. It's quite nice. The domain is x is an element of negative infinity to positive infinity, or like I've said before, you can write X is an element of real numbers. Yeah. So you have to keep close to that. Yes, but it's better to go, you have to be stronger. Okay, and then the range, now guys, the range is the one that's going to depend on your asymptote. Okay? Because can this graph can it be equal to the asymptote? No. Can it go below the asymptote? Yeah. No. So what was the asymptote again? The x-axis, but this was actually y equals 0, right? So what do you guys think? What is the range of this graph going to be? Y has to be bigger or smaller? Bigger than 0, hey? Greater than 0. Can it now be equal to 0? No, because it's the asymptote. Okay, so it can't touch that 0 value. So you have to say y is greater than 0. If your asymptote was at 2, you'll say y is greater than 2. If it was below the asymptote, right, we'll do an example now where it's underneath the asymptote, then you're going to say smaller than whatever that asymptote is. Okay. Yes, you can. Yeah. Yeah, so if you know you're gonna have to do a round bracket here, yeah, because it can't be equal to 0. Okay, so if you want to write it in this method, or in this notation, thank you, you can write it like that. Okay, so 0, but because it can't touch that asymptote, it can't be equal to 0, you have to use a round bracket. Okay, any other questions about this one, guys? Okay, let's do one that is a bit more complicated. And we're going to look through one that is negative, but that has an X-intercept. Looks like that's a full order. How much time do we have? 15 minutes already. Okay, okay, I'm gonna have to do another one that's positive, just so that we can do one with an X-intercept. Should I not? Is that good enough? Okay, guys, let's do another example. We'll have to do an example that's negative tomorrow. That's fine. We still have tomorrow for these ones. So number 2. Let's do y equals 2 times 5 to the x plus 1 minus 2. Okay, is my A value, remember it's A times B, right? Is my A value positive or negative? Positive, right? It's 2, yes? So A is positive, so we know that this graph is going to be above the asymptote. What is the asymptote in this case? -2. Okay, so there we go. The horizontal asymptote or just asymptote, you don't have to write horizontal asymptote, it doesn't matter, is y equals -2. So we are going to have to draw that in as a dotted line. Okay, and the previous one it was with the x-axis, so we didn't have to draw it. Okay, next up we need to find the y-intercept. I'll just do it here on the side. So for the y-intercept, remember you make x equal to 0. So we're going to say y is equal to 2 times 5 to the 0 plus 1 minus 2. You can type that into the calculator if you want to. You don't even have to write this calculation down. Okay, you can just do it on the calculator. But for the examples, let's write it down so that you know what you're doing. Okay, so this is 2 times 5, right? 0 plus 1 is just 1, so this is 5. So 2 times 5 is 10 minus 2 is 8. Okay, so we're going to have a y-intercept at 0 and 8. Okay, X-intercept. For the X-intercept, we are going to make y equal to 0. Now guys, for the previous one, we didn't even do this because the x-axis was an asymptote. Right. And because the x-axis was an asymptote, we knew that we're not going to have an x. Okay, so we didn't even try and calculate it. We wouldn't have been able to. All right, so here we're now going to take this equation and make it equal to 0. So we're going to say 2 times 5 to the x plus 1 minus 2 is equal to 0. Now we need to solve for x. Okay, so we need to systematically move everything over to the other side. Remember when we solve the equation, we do bypass backwards, right? So when we are simplifying something, we would have to like times first. But now because we're working backwards, we have to do the minus first. So this minus 2, we're going to move over. It's going to become positive 2. So we're going to be left with this whole term. And 0 plus 2, right, is just going to be 2. Okay, so we're moving that minus 2 over to the other side. Next up, I'm going to have to move that 2 over to the other side. What am I going to do with this? Divide. Good. So I have 5 to the power of x plus 1 is equal to, what's 2 divided by 2? 1. Now guys, do you remember with exponential equations, if your variable is in the exponent, once you have your base with the exponent equal to a number, you have to make the bases the same. So I bring a ball. Let's write here on the side. Make bases the same. Now this is a bit of a tricky one. This has a bit of a trick to it. Because if it was 25, we will just say it's 5 squared, right? We have a 5, a base of 5 on this side, meaning I need to have a base of 5 on this side as well. Guys, 5 to the power of what is going to be 1? 0, hey. So this is going to be 5 to the x plus 1 equal to 5 to the 0. Okay, now that our base is all the same, we're going to have to make our exponents equal. So now we're going to say, therefore, x plus 1 is equal to 0. So what is x? What if I do with that plus 1? It's going to become a minus 1. So I'm going to have x equal 0 minus 1, so negative 1. Okay, so all of that working to get the x. Okay. Like I said, this is possibly going to be what might be problematic. So we're going to practice a whole bunch tomorrow. Okay. How many points do we have? We need 3. We have 2 currently. Hey, we have an asymptote, we have our y-intercept, and we have our x-intercept. Now guys, is the x-intercept positive or negative? Negative. Negative. So we're going to have to choose a positive x value. Okay, so let's write that down. So I'm going to say here, x-intercept is negative therefore choose a positive x value. Oh, sorry. We need one positive point and one negative point. All right, so whatever your x-intercept is, if it's negative, you're going to choose a positive one. In the previous question, we had to choose a negative and a positive one because we didn't have an x-intercept. Okay, but now we just need to choose a positive x value. So guys, since we had -1, I'm going to choose +1. All right, does that make sense? Just so that it's kind of symmetrical. So I'm going to choose x equals 1. I'm going to write it over here, x equals 1. And we sub that value into the equation of the graph. So we have y equals 2 times 5 to the 1 plus 1. Is that correct now? 5 to the x plus 1, yeah? Minus 2. Now guys, unfortunately with exponential graphs, often you're going to get values that aren't very nice, right? So this is actually tough one to draw. Okay, what? This is 5 squared, which is 25 times 2, 50. Minus 2 is 48. Sure, I don't want to draw this graph. What about if we do a smaller x value? Let me quickly think. What if we do a half? Then we're gonna have, is it 24? Can someone just type that in quickly? 2 times 5 to the 3/2. Yeah. No, so sorry. It was just 3/2, not a +1. So 2 times 5 to the power of 3/2, and then minus 2. Even that. Okay, it is better. Okay, guys. What I'll do tomorrow is I'll just show you this graph with the graph. Maybe I'll put it in our. Okay, so let's write this down. We have the point 148. Lovely. I'm just going to type it into autograph quickly. We still have 7 minutes, so you don't have to panic to get out of here. Okay, let me quickly type this in, and then I'll show you what it looks like. Guys, shame, we won't give you graphs with such hectic values. Okay, sorry, I was just looking at the table, and I was just looking at what is the x-intercept and what is the y-intercept. I didn't realize that it was so steep. Okay, autograph. Do I even still have it on here? Let's see. Online graph calculator. Let's see. Okay, guys, autograph isn't on this PC, so I just searched now for online graph calculator. Let's see. Y equals, what's that equation? 2 times. Now I wonder how do I put a times in here? Is it? Oh, thank you. 2 times. Okay, yes, thank you so much. 5 to the power of x plus 1. Hey. Oh no, wait. I must put a bracket, I think. X plus 1, okay, and then minus 2. Okay, so now, oh dear, what's happening here? Oh, I see. Okay, So guys, they didn't draw the asymptote here, but do we see that the asymptote is at -2? Now, it kind of looks like it's touching the asymptote, but if we keep zooming in forever and ever, we're going to see that it actually doesn't touch the asymptote. Okay, so I'm going to zoom out again. So our asymptote would be a dotted line at -2, and then there we have our x-intercept, which was what? -1. Hey, that's 0, 0, -1. There we have our x-intercept. Our y-intercept was at 8. You see that it is over there. And now if we go all the way up to 1, what did we get? 48, hey? 1 and, oh, I'm still going. 1 and 48. It looks like it's here somewhere. There we go. There is that point that we got. Okay. So sorry guys that it worked out that the values were so big. Now we're going to do, I'll prepare properly for tomorrow and I'll find ones that are easy to draw. Okay, and that is what we're doing tomorrow. We're just practicing drawing. I'm not going to give you homework because I know that you have a big night ahead.